everyone, and welcome back to the Analytics series where we focus on core concepts about data. My name is Temi Aremu, and I'm a solutions architect at Amazon Web Services. And today we'll be talking about databases, data lakes, and data warehouses. We'll discuss the major differences between them, how they work, and use cases that you might be able to relate to. With that being said, let's get right into it. I'll start us off with what a database is. A database is a systematic collection of related information or data that is stored electronically in a way that's easily accessed, retrieved, managed, and updated. Databases help to facilitate the storage, retrieval, modification, and deletion of data. They typically collect information on people, places, or things. Now, there are different types of purpose-built databases, typically chosen to support diverse data models based on the organizational approach that has been chosen by the business. These include relational, key value, document, in-memory, graph, time series, wide column, and ledger databases. Before diving into operational databases, it is important for companies to define their data strategy that aligns with the business. The decision about which database to use is a design and modeling decision as well. It can be as easy as evaluating your transactional data requirements and using that as a framework for choosing the right database. Databases can be used for a variety of use cases like banking transactions, session management, fraud detection, e-commerce systems, and so on. For example, social media platforms use document and graph databases to store user information such as names, email addresses, and user behavior. The data that is stored and collected is then used to recommend content to the users and to improve the user experience. So why are databases so important, you could ask? Well, businesses rely on databases and the data collected to make informed decisions, which could be crucial to profitability. Databases also help organizations to provide a tailored set of products and services to customers, improving their experiences and augmenting retention. For example, organizations use their databases to improve business processes by collecting data such as sales, order processing, and customer service. Businesses analyze that data to improve these processes, expand their business, and to also grow revenue. Another instance that businesses use data for is to store personal health information. Healthcare providers use databases to securely store personal health data to improve patient care. When we think about selecting the right database for applications, it's mainly choosing between two types of data processing systems, which are online analytical processing, also known as OLAP, and online transactional processing, also known as OLTP. The major difference between the two is that OLAP is used to gain valuable insights, while OLTP is purely operational. OLAP is typically used for performing analysis on large-scale data sets at high speeds, while OLTP helps us capture and maintain transactional data in a database. Choosing the right system for your application mainly depends on your objectives. OLAP can be used to unlock value from large-scale datasets. Meanwhile, in a situation where you need to manage large transactions, we can use OLTP to help manage processing of large amounts of data or transactions per second. That leads us to our next topic, data warehouses. I like to think of data warehouses as a central repository of information that can be analyzed to make more informed decisions. Data can flow into a data warehouse from transactional systems, relational systems, and other sources, typically on a regular cadence. A data warehouse centralizes and consolidates large amounts of data from multiple sources. Because of these capabilities, a data warehouse can be considered as an organization's single source of truth. So how does a data warehouse work? A data warehouse may contain multiple databases. Within each database, data is organized into tables and columns. Within each column, you can define a description of your data, such as integer, a data field, or a string. Tables can be organized inside of schemas, which you can think of as folders. When data is ingested, it is stored in various tables that are described by your schema. Query tools use the schema to determine which tables to access and analyze. Some benefits of using a data warehouse include informed decision-making, historical data analysis, data quality, consistency, and accuracy, and separation of analytics processing from transactional databases, which helps improve the performance of both systems. And lastly, what is a data lake? A data lake stores structured, semi-structured, and unstructured data, supporting the ability to store raw data from all sources without the need to process or transform it at that time at any scale. So why do you need a data lake? Typically, the main purpose of a data lake is to analyze the data to gain insights. By having all of your data consolidated in one location, you're able to perform analytics like data transformations and machine learning over data sources like log files, data from click streams, and social media pages stored within a data lake. Another benefit of storing data in a data lake is the ability to store data in a variety of formats, including JSON and Parquet. The ability to harness more data from multiple sources in less time empowers users from multiple lines of business to collaborate and analyze data in different ways, leading to better and faster decision making. Examples of where data lakes can add value include aiding customer interactions by helping combine data to empower the business, increasing operational efficiencies that in turn help reduce operational costs and increase quality, and improving research and development innovation choices. So how do databases, data warehouses, and data lakes work together? Conventionally, businesses use a combination of all three to store and analyze data. By following one or more common patterns for dealing with data throughputs for your database, your data lake, and your data warehouse is helpful as the volume and the diversity of your data grows. For instance, you can either land your data in a database or a data lake, prepare the data, and then move selected data into a data warehouse, and then perform reporting. Or you can land data in a data warehouse, analyze the data, and then share data to use with other analytics and machine learning services. To round things up, we've seen here that a database, a data lake, and a data warehouse all work towards providing different ways of efficiently managing your data. And the end result is an organized and structured environment that can provide businesses with processed data to spur effective decision-making processes. By understanding these differences, I hope you have a bit more insight and that this helps you select the most effective data storage solution that fits your data needs and use cases. Thanks for watching. Please subscribe to the channel and smash that notification bell to get alerted for new content. Also, comment on aspects of databases, data lakes, and data warehouse that you would like to learn more about here. See you next time.
Hey there! Thanks for checking out this video. Remember to give it a like and share with your community. Then hit subscribe and the bell for all the latest content that will help you build on AWS.